Online signature recognition and verification in Telugu script. Abstract signature recognition and verification is an active field of research today, comprising of a variety of feature extraction techniques. Online signature recognition has gained enormous attention recently due to its vast application in various fields. In this article, the different techniques for the recognition and classification of signatures are analyzed. The signatures, in one of the most popular Indic scripts, Telugu, are examined dynamically at the time, when they are being fed as input to certain electronic digitizers, for example, a tablet. The current method uses multiple structural and directional features, analyzed in elliptical regions of the input image, to extract feature values from strokes of text and non-text data. The features are then studied in classification platforms based on support vector machine, SVM, approach and hidden Markov model, HM. The probabilistic outcomes of these two classification platforms are then combined using the Dempster-Shafer theory, DST, to improve the accuracy rate. Keywords online signature, SVM, HM, classification, DST. Introduction. Due to the recent advances achieved in hardware technology and the growing popularity of handheld devices, such as personal digital assistant, PDA, mobile phone and ultra-mobile PC, UMPC, new methods for the input of speech and handwriting have been developed, thus making character recognition an active field of research in the modern world. This paper deals with the online recognition and verification of signatures in Telugu and Indian script. This mechanism of recognition uses a different feature space and concept of elastic matching in the form of dynamic time warping, DTW. The classification among different classes has been done by a KNN classifier. Handwriting recognition is a part of pattern recognition. It has a varied use in modern scenario ranging from signature recognition and verification to handwriting recognition. The remaining portions of this paper are arranged as follows. Section 2 details the related works. Section 3 discusses the Telugu script and method of dataset creation. Section 4 lists on the pre-processing steps taken. Section 5 depicts the feature extraction technique. The processes of classifying text and non-text data separately using SVM and HM as well as by combining them are discussed in Section 6. Experimental results and analysis are discussed in Section 7. Finally, conclusion of the paper is given in Section 8. 2 Literature survey. Although limited studies are available on classification of text and non-text portions from within a single online handwritten document and a few non-Indian scripts, we were not able to find any research work in this specific area in Telugu script. A few studies, available in non-Indian scripts regarding this, are discussed here. Kashi et al. 1 proposed a hidden Markov model approach to online handwritten signature verification. A hidden Markov model, HM, is a statistical Markov model in which the system being modeled is assumed to be a Markov process with unobserved, hidden, states. Sahai et al. 2 proposed a multi-section codebook approach for online signature recognition. This algorithm considers the temporal evolution of the signature and obtains a significant speed improvement, which is estimated to be around 47 times. Zhang et al. 3 presents a new 3-stage verification system, which is based on 3 types of features: global features, local features of the corner points, and function features that contain information of each point of the signature. In this approach, signature verification is based on the comparison of input and reference signatures, involving both static and dynamic analysis. In Barkawa et al. 4 approach, we see the signatures TAS and TAS representations and their application to online signature verification. In the matching stage, a variation of the longest common subsequence matching technique has been employed. 3 Data collection in Telugu script. All the samples were collected from the students in National Institute of Technology, Putna via an electronic tablet. For Telugu script, a total of 600 samples were collected. Out of which, 300 were the original signatures, made by students. We collected 5 signature samples each from 60 students. Original samples count, 60*5 equals 300 samples. Also, we collected 300 forged signatures, 5 signature samples each from 60 individuals. Fake samples count, 60*5 equals 300 samples. This helped in bringing the sample data size to 600 samples. Total samples count, 300, original, plus 300, forged, equals 600 samples. For pre-processing. Online signature verification involves taking signature from the user using devices like touchpad and mobile device. The input sometimes might not be compatible with our algorithm. There can be issues like extra brightness, low intensity, sharp broken lines, incomplete points, and others. To get this sorted, we pass the input through many stages of pre-processing. These stages have been shown here diagrammatically. A. Interpolation. In the mathematical field of numerical analysis, interpolation is a method of constructing new data points within the range of a discrete set of known data points. In engineering and science, one often has a number of data points, obtained by sampling or experimentation, which represent the values of a function for a limited number of values of the independent variable. It is often required to interpolate, i.e. estimate, the value of that function for an intermediate value of the independent variable. This may be achieved by curve fitting or regression analysis. This approach preserves time dependencies, keeping a high spatial density of samples in slow strokes and a sparser sample distribution in high-speed strokes. B. Smoothing. In statistics and image processing, to smooth a data set is to create an approximating function that attempts to capture important patterns in the data, while leaving out noise or other fine-scale structures/rapid phenomena. In smoothing, the data points of a signal are modified so individual points, presumably because of noise, are reduced, and points that are lower than the adjacent points are increased, leading to a smoother signal. Smoothing may be used in 2 important ways that can aid in data analysis. 1. By being able to extract more information from the data as long as the assumption of smoothing is reasonable, and 2. By being able to provide analyses that are both flexible and robust. Many different algorithms are used in smoothing. Here we have used average method to get the average point between 2 consecutive points to get the smooth curve. C. Resampling. Image resampling is the process of transforming a sampled image from one coordinate system to another. The 2 coordinate systems are related to each other by the mapping function of the spatial transformation. The inverse mapping function is applied to the output sampling grid, projecting it onto the input. The result is a resampling grid, specifying the locations at which the input is to be resampled. The input image is sampled at these points and the values are assigned to their respective output pixels. Resampling implies changing the sample rate of a set of samples. In the case of an image, these are the pixel values sampled at each pixel coordinate in the image. Denormalization. The main goal of this pre-processing step is to ensure that the same characters have the same height for every handwritten signature. This is accomplished by transforming every signature to a given corpus height, where the corpus height is the distance between the baseline and the corpus line. Note that the total height of signatures may still vary after normalizing size, even for the signatures having same corpus height. V. Feature extraction. The feature extraction plays an important role in overall process of signature recognition. Many feature extraction techniques have been proposed to improve overall recognition rates, however most of them are dependent on the size and slope of the signature. They require very accurate resizing, slant, correction procedure of technique, otherwise they achieve very poor recognition rates. To extract features like standard deviation, curliness, writing direction, curvature, slope we have used two methods, elliptical method, and NPE and on global basis method. These are described in detail, below. A. Elliptical technique. The feature extraction phase gives a matrix containing feature values of each sample identified by row. This sample is either training dataset or test dataset. These datasets are fed as an input to the classification phase, or further processing. The following 5 features were used: standard deviation, curliness, writing direction, curvature, and slope. In this technique, we make multiple concentric ellipses on the plane of the signature. The outermost ellipse covers the plane fully, touching the vertices of the plane. Then other ellipses are drawn having lesser radii and sharing same center point. The properties are extracted from the area between two consecutive ellipses. The feature values are saved in a vector matrix in the form of rows and columns. Each elliptical region is divided into octants called bins. The number of feature values obtained from each region is 5. Figure 1 shows the partition of plane by 4 number of ellipses and divided into octants. B. NPEN on global basis. We have also used NPEN approach to extract features, like standard deviation, curliness, writing direction, curvature, and slope. In this approach, we directly extract the features from the whole signature without dividing it into further regions. Figure 2. The feature vector size for each sample was 50. Size equals 8, slope, plus 2, std_dev, plus 16, curvature, plus 16, writing_dir, plus 8, curliness, equals 50. 6. Classification. Classification in online signature verification and recognition refers to the classification of the test data or sample into their respective class labels. These class labels tell the class of the sample. There should be a high level of accuracy during classification because it lays the basis for further recognition phase. If classification is not correct, then recognition will be even further bad. So, there is utmost need of better classification. However, it is impossible to get 100% accuracy during classification. It is evident that there will be some amount of incorrect classification, but it should be as less as possible. There are 2 types of data set that needed classification phase in 2 different manners. 1 training set data. 2 test set data. The classifier used here is support vector machine, SVM, hidden Markov model, HM, and hidden state conditional random field library, HCRF. These are described in detail below. A support vector machine, SVM. In machine learning, SVMs are supervised learning models with associated learning algorithms that analyze data and recognize patterns, and are often used for classification and regression analysis. Given a set of training examples, each marked for belonging to one of 2 categories, an SVM training algorithm builds a model that assigns new examples into one category or the other, making it a non-probabilistic binary linear classifier. An SVM model is a representation of the examples as points in space, mapped so that the examples of the separate categories are divided by a clear gap that is as wide as possible. New examples are then mapped into that same space and predicted to belong to a category based on which side of the gap they fall on. In addition to performing linear classification, SVMs can efficiently perform a nonlinear classification using what is called the kernel trick, implicitly mapping their inputs into high-dimensional feature spaces. In machine learning, kernel methods are a class of algorithms for pattern analysis, whose best known member is the support vector machine, SVM. The following kernels have been used here: linear kernel, polynomial kernel, and radial basis function kernel. B. Hidden Markov model, HM. A hidden Markov model, HM, is a statistical Markov model in which the system being modeled is assumed to be a Markov process with unobserved, hidden, states. A method for the automatic verification of online handwritten signatures using both global and local features. A HM can be presented as the simplest dynamic Bayesian network. We get the names of the person and their index number in the result file created in the process. If the index number and the corresponding name is incorrect, as an original state, then the sample is discarded. See Hidden State Conditional Random Field Library, HCRF. HCRF is a C++ library for training and inference of conditional random field, CRF, hidden state CRF, HCRF, and latent dynamic CRF, LDRCF, models. This library implements 3 main models: conditional random field, CRF, hidden state conditional random fields, HCRF, and latent dynamic conditional random fields, LDCRF. We implemented 2 variants of the HCRF model. The CRF and LDCRF models can be applied to unsegmented sequences, while the HCRF and GHCRF should be applied to pre-segmented sequences, only 1 label per sequence. The HCRF library can be easily installed on a Microsoft Windows system using the IntelliShield installation package. The HCRF library comes with a demo program called testhcrf.exe. This program can be used to train and test CRF, HCRF, and LDCRF models from the command prompt. The demo program testhcrf.exe is called using the following syntax: testhcrf.exe ttd filename L filename D filename L filename M filename F filename R filename OCGBFGSASA CRF LDCRF HCRF GHCRF. 7 results. Different metrics can be used to rate the performance of a biometric factor, solution, or application. The most common performance metrics are the false acceptance rate FAR and the false rejection rate FRR. The 2 indicators used for measuring performance of any signature verification and recognition system are FAR, false acceptance rate, and FRR, false rejection rate. A FAR, the FAR or false acceptance rate, is the probability that the system incorrectly authorizes an unauthorized person, due to incorrectly matching the biometric input with a template. A system's FAR typically is stated as the ratio of the number of false acceptances divided by the number of identification attempts. BFRR, the FRR or false rejection rate, is the probability that the system incorrectly rejects access to an authorized person, due to failing to match the biometric input with a template. It is stated as the ratio of number of false rejections to number of identification attempts. A conclusion. Automatic signature recognition and verification is a very attractive field from both scientific and commercial points of view. It is an emerging and trending field of pattern recognition which finds its utility in applications which are used for recognizing signature as well as languages having large characters, Japanese, Chinese, script identification, and so on. In this project we tried to explore this field and novel our idea of feature extraction to gain reasonable and acceptable accuracy. With our efforts we were able to achieve promising results. The best results for a common threshold are obtained with a feature set consisting of the local and global features. We obtained accuracy of 80 to 90% for Telugu. These are quite promising results. Thus, we can say that our proposed approach can be used as it is for Telugu. To conclude, we can say that our proposed approach, system, works quite promisingly and can be further explored to enhance its capabilities so that give even better results. As a part of future scope, we can include word recognition, script recognition, application on other scripts, Indian as well as Western, with structural features and so on. Based on the above feature, vector classification was performed using support vector machine as classifier. The platform was identical for both the approaches before classification, i.e., the same dataset was used for training as well as testing and comparative analysis of both approaches to obtain results. We have so far obtained 87% accuracy in linear kernel in Telugu signatures. From the above result, it seems to be evident that our proposed approach works well as far as classification of Telugu strokes is concerned, based on spatio-temporal features.